this video, we will learn how the hard and soft constraints work in anyLogistix. Let's take a simple supply chain on the territory of France. We've got two distribution centers that are supplied from the port Le Havre and 100 of customers that are generating demand for kitchen paper towels. Let's run the network optimization experiment and observe the results. We see that the supply chain works well. We have generated certain profit. The demand is completely fulfilled. Now we will assume that we want to decrease the load of our distribution centers to optimize expenses. This can be done in the product flows table. We need to set the maximum product flow for DC1 and DC2 to 450,000 items and 600,000 items respectively. As you can see, the product flow from the supplier is currently defined for a group of distribution centers. We will not create new records. Instead, we will expand the existing record by destinations. Now we can define the maximum throughput. The values that we provide will act like hard constraints. A hard constraint is a condition that can't be violated. In our case, it means that at a certain point, the DCs will no longer receive products from the supplier. Let's run the experiment and see how it goes with a hard constraint. Well, we made negative profit this time, which is predictable, since by limiting the throughput we blocked the product flow and customers simply couldn't receive the demanded products. Let's switch to the demand fulfillment table to see the statistics. Yes, here it is. Lots of unfulfilled demand. What can we do about it? To satisfy the demand, we'll create a new distribution center that will be used when prompted. Let's do this. First, we place the new distribution center anywhere in France. Now we name it DC3, disable the initially open toggle button to make it closed at the beginning of the experiment, and set its inclusion type to consider. The inclusion types of DC1 and DC2 must be set to include. We know that this DC will have certain operating costs. In the facility expenses table, we will create two records to define the initial cost value and other daily expenses. To complete setting up this DC for our supply chain, we need to define a product flow and product storage for it. In the product flows table, we will create two records for this DC, one with the incoming product flow from the supplier and the second one with the outgoing product flow to all the customers. Finally, in the product storages table, we will create a new record with the DC's storage policy. There, we have defined a new DC. It is closed by default and opens when the first two DCs reach their product flow limit. We're good to go. Let's see what happens now. As you can see, we made some money, which is good. We can instantly see that DC3 is in the game. Also, its expenses are detailed on the site status page. Here it is, $10,000 for opening this DC, and on the other costs page, there the daily expenses. If we check the demand fulfillment table, we will see that there is no unsatisfied demand this time. Great, worked like a charm. Now, wouldn't it be interesting to see if keeping this DC is actually worth it? Perhaps it would be cheaper to increase the product flow for DC1 and DC2. We don't want to revert the decision we made on limiting the throughput. We still intend to keep the flow at the defined level. So how do we do it? We need to make this hard constraint a soft constraint, so that the solver would have an option to violate the defined maximum throughput level when required. In the product flows table, you can see that there is no penalty for violating the constraint. By specifying the penalty to be paid per product item that is sent beyond the maximum throughput limit, we tell the solver to consider the option of increasing the product flow for DC1 and DC2. The solver will now compare the expenses for opening DC3 with the penalties for increased product flow to DC1 and DC2. Now, if we run the experiment, we will see that the solver chose not to open DC3, but pay the penalties instead, which can be observed on the overall states page. That's it. This is how hard and soft constraints work. Thanks for watching. I hope you enjoyed the video. Leave your comments and subscribe.